Hello, and welcome back to another Craig and Dave Unscripted. So it's just us two this week. We've had a flurry of guests on over the last couple of months, but it's just us. And we thought we'd talk about something which, if you are a bit of a techie geek like Dave and I, probably hasn't gone unnoticed. And that is the official announcement. It's been rumored for a while. The official announcement of Windows 11, the operating system that was never meant to be. But I'm sure we'll get onto that in a minute, Dave. So hot topic. It's officially been announced. I don't think there's an actual date yet. If you go to the site, you can learn about it and you can read about the requirements and the features, and we're going to touch on those today. But no official date as to when it's coming. But it's official. Windows 11. So we're going to split this into two halves, aren't we, Dave? We're going to have a look at some of the the main new features, the things they're kind of pushing out on their showcase, and then we're going to look at the system requirements for Windows 11, which are hefty, but also there's some interesting little gotchas in there which we're going to discuss. So we'll dive straight in then. Right, Dave, why don't you take us away then?
Yeah, well, for a start, like you said, it's the operating system that was never meant to be. I mean,
yeah.
I remember, for example, I remember every single release of Windows. Let me put that out for a start. I remember Windows 1, but let's not go on a complete, tour. I remember Windows 8 especially because everybody hated Windows 8, and I loved Windows 8 in the sense that it was supposed to be a truly unifying operating system. It didn't matter whether you had a phone, whether you had an Xbox, whether you had a PC. The Windows interface and the Windows architecture was, supposed to be pretty much the same on all those platforms, obviously dumbed down for the mobile phones and Xboxes and things like that. But it was supposed to be a unified interface. And I thought this was an amazing idea. And of course, it went down like a lead balloon with the community. And very quickly, they kind of went on to Windows 10, which kind of brought back the Windows 7 sort of interface, as it were. And I thought that was quite an interesting step. And they missed out Windows 9 and went to Windows 10. And they said that Windows 10 would be the last ever release of Windows.
That's
not that
right.
Windows was going to completely disappear, but the plan was to just do continual incremental updates. And I noticed, for example, with my PC, that I come to use it and it's kind of slightly different to how it was yesterday. And it's a bit disconcerting. It's a little bit weird, but it always wants to do the Windows updates, at a time when I want to kind of use the maximum kind of CPU usage, and it's always doing something in the background. And I know you can change the time, the scheduling time and everything, but it always wants to be doing something, and it's a bit annoying. So kind of going back to this idea of having annual releases of Windows or something like that, I think is probably going to be something the community welcome. And I'll be honest, I'm very much a kind of shiny and new person. If you show me something that's shiny and new, I'm like, ooh, it's shiny and new. I kind of love that.
I get like we were doing with Windows 10. It's like when we tell students when they're designing computer programs, especially big ones for their project, thinking about maintainability and future use. And there's a lot of experience there at Microsoft, clearly, in years of development. It's like, right, Windows 10 has been built in such a future-proofed way, in such a, I'm not going to pretend to know how it's designed, but such a modular way that actually we can expand this indefinitely. We've got a model here, we've got a design to this product that we don't need, to the point where they said this is the last version. Of course, the irony is it doesn't matter how smart you are and how well you design these things. Years go on, there are advances in technologies, different ways that people want to work together collaboratively, and there comes a point where like, this isn't built for what we need to do from the ground up. Yeah, but we said it was always going to be, and they've changed their mind and gone, no, it's a new release. All right, let's get into the features then.
So perhaps the biggest new feature is like, how could I possibly live without this? Let's move the Windows button from the left to the middle. What do you make of it?
What I make here is that Apple Mac users up and down the country are going, really? That's how we've had our desktop since day one. But this is this is not a Microsoft Windows bashing or a competition of whether you prefer Mac OS or Microsoft. But yeah, I mean, they've moved it to the middle. And of course, the start button is there. There was that whole period of Windows where it disappeared, and then people had plugins to bring it back, and then they brought it back. Yeah, so they've brought it back to the middle, and they've introduced pinned apps. But again, not a. I wouldn't say that's revolutionary new, is it, Dave? Let's be honest. You can kind of pin apps to your taskbar, and you've done a similar thing. I mean, it's more explicit, but yeah, that's one of the big features.
Yeah, exactly. They've gone from, when Windows 10 was released and they kind of corrected the error of their ways from Windows 8. I kind of quite liked the tiled interface, as I said. So the fact that they merged a kind of Windows 7 interface with a Windows 8 tile sort of approach, sort of that Metro effect, I think it was called. It was fine. I don't have a problem with it. I'm not quite sure what these pinned apps are kind of doing for me that I haven't got already, if I'm perfectly honest.
No, but anyway, that's one of their big features. Okay, on to the next. Right, yeah, the ability to run Android apps natively through your PC. Yeah, this is good, and you can see here they're also coming into this understanding and age that, you know, all our kind of media and our consumption of television and movies is so predominantly now through streaming sites, especially since the pandemic. I mean, that's just accelerated it as well. So full integration of things like Disney Plus and Netflix straight into the platform. It makes total sense. It's just what people expect. It's how people consume media these days. But yeah, interesting on the Android apps on your PC. I mean, any thoughts on that?
Yeah, sorry, I didn't know whether you'd finish what you were saying there. Yeah,
that's right.
Yeah, what I'm not 100% sure about is when they say Android apps on your PC, download them through the Windows Store. Have we effectively got an emulator here that it's kind of running those apps on? Because obviously those apps are built for an ARM architecture, which is completely different to the x86 architecture that your PC is using. So I don't know if there's a layer of emulation in there or not. I genuinely don't know. But the fact that you can have those apps now on a PC, I think is absolutely fantastic. Yeah.
Yeah, that's an interesting point, because I just kind of off the cuff said natively run Android apps on your PC without even thinking about it. If that is indeed what they're supporting here, then indeed, what are they actually doing? But again, this is a way they need to go. I mean, I'm a bit of a computer gamer, as you know, Dave, and it frustrates me the amount of times I go to play a game on PC or PS5, and my friend's like, "Oh, well, I've got it on the other one." There's so little reason they cannot be cross-platform play. You know, even games on the Xbox, there's only a subset of those which are cross-play between PC and Xbox, and it's the same underlying operating system. Now, the gaming industry is starting to veer away from that. Fortnite was the first big example that blew that out. What do you want to play Fortnite on? Anything you like. Mobile, Xbox, doesn't matter, and you all play on the same servers. It can be done. Now, I get what they're doing. They want you to buy into their ecosystem, and therefore they want to make it exclusive. But I think we are coming to the age now where people are expecting this kind of seamless integration. I should be able to get something over here. Doesn't matter that I've got an Android phone. I should then be able to access it on my Windows PC. I should be able to pick the app up from my smart telly, and so I think this is a nod to, you know, that way of working.
Yeah, well, of course, the difference with crossplay there is that it was not really possible in the past because of the different architectures of the different devices. But now that you've got the PC and the Xbox One and the PlayStation 4, PlayStation 5, all running the x86 architecture, means that there's no technical reason now why you can't do this. You know, they are all PCs, just of varying specifications under the hood. There's no real difference. So it kind of comes down now to how big and influential are you, and how much money have you got. And you know, if you're Fortnite, then you can legitimately approach Sony and Microsoft and say, well, we're the biggest game in history. you've got a choice. You can either have us on your platform or you don't. You know, it's up to you.
Yeah.
or if you've got enough money, perhaps you can then stump up and say, well, you know, it's up to you. We've got a few million to spend, but it's up to you whether you want it, you know. But you're absolutely right. I think that, you know, this idea of cross-platform or, you know, run any app anywhere is definitely the future. I mean, my personal view on this, and I've been saying this for decades, but nobody kind of believes me, is that I do think that we are approaching a time where thin client will be the thing. Your PC will simply be a monitor and a keyboard. There will be no processing other than a tiny bit of local processing, and everything will be in the cloud. Now, of course, Google sort of tried that with their, I've forgotten the name of it, maybe you can remember, their sort of online game system where you can play games through your TV and you've got a little controller, and it was all in the cloud, and they kind of dipped their toe in it. But of course, the server architecture and the network bandwidth across the internet is still not there. But we're approaching a place where, you know, you won't need local apps. Everything will be in the cloud, and there will be a version of Windows in the future where you don't install it. It is literally running on the server, and you can do that thin client now, you know, on local area networks and whatnot. But I think the whole computing industry is going that way. I don't know what you think.
No, I agree, and I know the Google thing you're talking about because my partner had one. Anyway, we're gonna get awfully distracted. We've done two features.
In the comments below. What was it called? We've forgotten.
Yeah. Oh, that's going to bug me. It might come to me. Right, next big feature they are pushing out, and these are from the official Microsoft Press Pack, by the way. So these are not features we've picked. These are the ones that they want people to know about. So widgets. Oh, look at this. Widgets. Absolutely groundbreaking. Sorry, Microsoft, they're not. Funnily enough, it was a few versions of Windows ago that they actually first introduced widgets. I remember you had to put them on the desktop, and they kind of faded out the background, but they've brought them back. Obviously, there's a lot more you can do with them now because these all rely on collecting data, processing data. You know, if the widget is useful and it's time sensitive and it's up to date, then they're useful. So, you know, and this is the era of it. We're used to these. We're used to these sort of things. Apps with live tiles on smartphones. But yeah, this is fully integrated and back in, I see.
Yeah, and they are useful, you know, they are useful if you make use of them. You know, an interesting little aside here, I notice, I don't know if you've noticed, Craig, the very latest version of Windows 10 that has kind of updated itself in the background.
I know what you're going to say.
Has got this tiny little widget in the bottom right hand corner that tells you what the weather is. Which is really helpful because, you know, I couldn't possibly turn around and look out the window and see what the weather is. You know, Craig has me focused on my work 100% of the time. But I don't know if you've noticed that little widget, the text is a bit blurry. And I don't know if you know why, because I do.
You know what? It is, isn't it?
Yeah.
And no, I don't know why. So tell me now.
Well, okay. Well, Microsoft have fudged it a bit, really. I mean, what is this all about? This is just lazy. What it's actually doing is it's showing you in the taskbar part of a web page. And because of that, the resolution isn't right. And so what you're seeing there is, yeah, it's crazy, isn't it? What are they doing? And so hopefully these new widgets, it's not going to be like that at all. And you know, we'll have actually have something decent.
I'm sure it won't be. Right. This next one is interesting, and I definitely have something to say about this, but I'll let you introduce this next one. There you go.
Microsoft Teams. Yes. Well, of course, the pandemic has brought these platforms to the fore. And, you know, one good thing that's come out of the pandemic is it has accelerated something that was going to take much longer in terms of, you know, team conferencing, working from home and all these sorts of things. So, you know, Microsoft and others worked very hard, very quickly to upgrade these video conferencing platforms. And, you know, I remember the days when to do video conferencing, you'd have to go into a special meeting room that had special cameras and audio equipment set up, and it was a right fiddle to get it all working, and nobody can be bothered. And now, of course, you can just do it from your desktop, you know, with no big deal. So I think this is great. I mean, I think the whole thing is great, but I don't know what's new because I've got a Teams app at the moment. So enlighten me.
Well, what was more interesting for me about this, I get what they're doing. They're totally integrating now, you know, from the ground up. This is not going to be an installed app. But what I think is interesting, and I was reading this the other day, is that obviously, although they haven't officially said it, this is unofficially the death of Skype for Microsoft. Now, remember, Microsoft purchased Skype in 2011 at the time for the single biggest, most expensive bite in history. I was just quickly Googling it while you were talking. I couldn't remember the amount. $8.5 billion. I mean, that is how sure they were in 2011. That's a decade ago now, that, you know, this was the way forward. And up until now, Skype has been installed by default since Microsoft took it over into Windows, and you have had to install Teams manually, you know, go and get it. This is definitely unofficially the death of Skype for them, because Windows 11 will be the first version since they bought it where Skype is not installed by default. So you would have to get it if you wanted it, whereas Teams is now fully installed. So it's clear the way they're going. Now, the underlying technology, I remember reading the article last week, the underlying technology between Teams and Skype obviously shares a lot of material. They took the stuff from Skype and put it into Teams, but it does kind of show the way they're going. If you are a real Skype lover, I think it's really had its day. It was the leading app. I remember using it and there was nothing, but now, as I said, with the acceleration that's been caused during the pandemic of the last year or two, things like Zoom and Microsoft Teams have come a huge way. So, yeah, that's it. If you're a Skype user, I'm afraid that's it. Teams is going to be the way they want you to communicate online, you know, between people for your video conferencing. It's installed by default. You won't be able to remove it. I quite like Teams. I mean, our school, Dave took it on board as our method for delivering virtual learning. And I'll be honest, I hadn't really had much experience with it before then. But yeah, you know, good product.
Yeah, I'd be honest, I've been quite impressed with our school. I mean, I've been impressed with schools generally during this time, but you know, I can only speak from my own experience at my own school. And you know, the transition to you know, online briefings and streams and
online assemblies,
all these other things. It's just like I wouldn't have been able to convince the school this was a good idea. It took a global pandemic for schools to wake up and realize the power of technology. And I do think it's been an amazing journey. And, you know, I do tip my hat off to the schools and the school leaders and the teachers who have coped with all this really, really well. It's been amazing.
Yeah. Okay, so a couple more features, then we're going to move on to requirements. So I'm actually sadly really excited about this one, Dave. Snapped grid layouts. I mean, yeah, up until now, you have been able to easily maximize a window to full screen or drag it to the left or right and it snaps to half the screen. But that is not enough configuration choices for me, Dave. I don't know about you.
Well, no, this is it. I mean, you and I both use a third-party tool to enable this because we want to have multiple screen layouts. We want to be able to divide the screen up into thirds and quarters, and you know, make it adaptable depending on what applications we're using and what we're trying to achieve. So to finally have this actually natively in Windows, you know, thank goodness for that. But again, it's because you know, I remember when people used to laugh when someone got a second screen. It's like, oh, you've got two screens. And, you know, people couldn't really understand, you know, why you would want two screens. Now people have got 3 screens, 4 screens. They've got a portrait screen and a landscape screen. They've got a 4-foot ultra wide screen. It's like, you know, if now could you possibly use your PC on a single 24-inch screen? I mean, I remember when my telly wasn't even 24 inches. So, you know, no, having been able to snap panels natively in Windows, absolutely fantastic. And of course, you've also got snap groups. I don't know if you know about this.
Go on. I don't think I do.
So snap groups is this idea of, okay, so you've got a couple of panels set up with your applications in them, and you can kind of make those a group, as I understand it. And then what that enables you to do is choose which groups you want to open. And when you open a group, it doesn't just configure, where the windows are. It also loads those apps into those windows. So if you say, good. Right, get me into video editing layout, it puts you in your video editing layout that you've laid out, but it also loads your video editor and other
well, that's good, because depending on what I'm doing, I do, like you, probably have a number of layouts, and if I'm working on editing resources, I will have a web browser, I'll have it over here, I'll have my file system and I'll have it over here in a smaller square, and I have, yes, you're right, I have exactly that. Okay, interesting stuff. I think it's fair to say, because I think we're coming to the end of the major features that they're showing here. I mean, I like the fact this is, new Windows 11. It does feel to me overall, though, and all of the features they show me, I think, they're good. It's the way forward. It's the way things should be going. This does feel to me like just overall an incremental change. It doesn't feel like a fundamental shift or leap forward as it was when you went from 3.x to Windows XP, or from 95 to 8. But I guess maybe that's the way we are now. I mean, it probably wouldn't be right to have a fundamental shift. It wouldn't, it would take you so far away from the experience people are used to. I don't think we can expect that anymore.
No, you can't, because over the years, people have become very used to the way the operating system works, and applications in general. And if you suddenly completely change the interface, then people get really upset because they like what they know. And I think that was one of the problems with Windows 8, to be honest. I mean, it was so different to Windows 7 that everybody was sort of, oh no, we don't like this anymore. It's one of the reasons why the save icon has looked like a floppy disk, for such a long time. I mean, I bet people don't even recognize the fact that it's a floppy disk. It's just the save icon, but it's what you're used to. And I think, I might be wrong about this, but I think they're changing that save icon so it's a bit more up to date.
No, I refuse. Right. There you go. That's what you were talking about. Yeah, snapping to grids and layouts. Perfect. Right. So that kind of concludes the first part there. We're just going over some of the new features that they're touting in their press pack. I'm sure there'll be other bits and pieces that will be released, but we're going to take a look now at the system requirements for Windows 11. Now, they're quite chunky, and there's that interesting couple of bits in there, but I'll let you get started then, Dave, and we'll discuss them. So these are the raw system requirements.
Yeah, so what I think would be quite nice here is if we approach this from a sort of A-level and beyond perspective, and let's just sort of talk a little bit about how this marries into what you learn at A-level in computer science, because I think that's interesting. So the processor, not a huge amount to say about that. So minimum 1 gigahertz processor, fine. 64-bit dual core. Okay, so let's take a pause there. What does that mean? So 64 bits is your word size. In other words, that's the size of your registers. How many bits can a single register hold? Now, if you've got a 64-bit memory address register, for example, that tells you the maximum addressable space that you've got. In other words, how big can the RAM be? Because you need to be able to address that RAM. So that's what we mean by a 64-bit computer and a 64-bit processor. So dual core, Craig, take it away. What's a dual core?
Yeah, so one chip multiprocessor with at least 2 CPU cores on it. So we've got 2 entire sets of control unit, ALU, set of registers. People will be like, "Wow, that's nothing these days. I've got quad core, I've got 8 core, I've got 16 core with 32 threads and all the rest of it." But it's interesting now that the minimum system requirements is 1 gigahertz. I remember, and I've come slightly off what you were asking me talking about, but I remember being excited probably about 10 years ago now, buying computing magazines when the first 1 gigahertz machines were coming out. They were cutting state of the edge. I can't speak today. Cutting edge technology, and now it's the minimum system requirements for Windows 11. 64-bit, forget 32-bit now. We're firmly in the 64-bit area, and we need at least 2 cores. We need to be able to run separate threads of processing at once, and that's minimum requirement. So, you know, it's really interesting. I was going to come on to this later, but I'm just going to mention it now. I looked up before this video, when I saw this slide, what the minimum system requirements were for the first Apollo rocket that went to the moon 45 years ago, or as it's technically called, what was it? It was the Apollo Guidance Computer, the single computer. It had a 2 megahertz processor, 2, and a
megahertz, not gigahertz.
Mega, and a 16-bit word length, or 15-bit plus 1 parity bit. I mean, crazy. I'm going to get onto its RAM when we talk about that in a minute, but you know, and that got people to the moon. Now, if you want a basic operating system, I need 1 gigahertz, 64-bit, and dual core.
Yeah, that's right. If you want to type up an essay on a Microsoft platform running Windows, then you need at least 1 billion cycles a second to be able to do that.
That's right.
Yeah, absolutely. And of course, dual core is important, and you kind of alluded to it a little bit there, Craig. But if you can be running the operating system on 1 core and the applications on another core, you've got parallel processing, and you haven't got the bottleneck of the fact that, you know, as part of the fetch, decode, execute cycle, you need to process the operating system commands, the scheduling algorithms and other things at the same time as the applications. And so to be able to, you know, relieve the main CPU of that pressure by having a dual core system is quite massive. And we saw this with the PlayStation 4, you know, when it went from the PlayStation 3 to PlayStation 4, and I realize we're on the PlayStation 5 now, but I'm just, you know, looking back for a minute, the idea that you could have a processor that was dedicated just to the operating system, and then the games, you know, had their own processor, you know, just meant things ran more smoothly. Simple as that, really. So
here under processor or system on a chip. Now that's definitely something which isn't in the specification. So what are we talking about there, Dave?
Yeah, well, system on a chip is quite simply where you've got on a single chip, you've got the processor and you've got the RAM. You may have the secondary storage, and you'll have the GPU, and you may have some other IO components as well. But it's this idea that on a single chip, you've got everything you need for a computational system. And of course, that's in contrast to your PC, where you will have a central processing unit, and then you'll have a separate chip that's your RAM, and you have a separate secondary storage, and you probably have a separate graphics card. So system on a chip just means the whole thing is on 1 chip. And of course, that's really useful for things like embedded systems, but it's also very useful for things like, you know, Raspberry Pi, for example. The Raspberry Pi has a system on a chip. You know, everything that it needs is on a single chip. And then if you want secondary storage on your Raspberry Pi, then you plug in an SD card or something like that.
Yeah. So moving on, RAM, minimum RAM, 4 gigabytes. Incidentally, 4 gigabytes was the maximum amount of addressable memory back when your computers were 32 bits. So, you know, that was the maximum you could have in your machine. I mean, well, I won't go off down a path. You could physically have more RAM than that in the machine, but your computer wouldn't know about it because it couldn't address it. A slight issue I had when upgrading one of my PCs once, insisting I got a 64-bit version of an operating system when you could choose. But yes, so the minimum RAM components are the maximum amount of addressable RAM you used to be able to have in a 32-bit system. And again, looking at the see how far things have come, the Apollo guidance computer that got people to the moon, 2048 words of RAM, remembering that a word was 15 bits plus a parity bit. that was the amount of RAM needed to get us to the moon. And now we need 4 billion bits of RAM available minimum. So, it's
bytes, isn't it? Not bits.
like, oh, no, I think, yeah. Noob mistake on a live. Yes, indeed. Yeah, you're absolutely right. And 64 gigabyte of storage. Again, these are hefty applications now, but I know we're being a bit flippant here. They are doing a phenomenal amount of stuff. I can't remember the number of lines of code that's spouted about when it's talked about Windows 10, but I don't think I'm wrong in saying it's in the billions of lines of code or millions. I'm going to have to check it. It's a huge number.
Yeah, I'm not sure about that. We'd have to look that up. But certainly I remember people talking about it being millions of man hours of code. In other words, if you had one person programming Windows from start to finish, it would take them longer than their lifetime. So that's quite interesting. Yeah.
Yeah. Now, this is what I'm really interested in, because this is actually something I didn't know, and I know you know a little bit more about, and I think we've got some other slides on this. So it's this trusted platform module. Now, if you're like me, I didn't know anything about this until very recently. So I think we have another slide on here just to help you just mention what this is. This is an interesting one.
Yeah, so this is what everybody is kind of talking about, and this is really what prompted us to do this video, because we thought it was a great opportunity to talk about TPM and what it means, because a lot of people won't know. So it's the Trusted Platform module, and you need a version 2 of that, and it sort of plugs into your motherboard. Now, if you've got a computer that is 2016 onwards, the chances are it's already built in, and it might be part of your sort of system on a chip, as it were. It might be part of your processor, or it could be plugged into your motherboard here. So you may not need to concern yourself about this, but there's also a possibility, if you don't have a TPM2 chip or capability of it, then Windows 11 will not run on your computer, and this is what's causing people to discuss it. So here you go. This is what it looks like. This is a TPM chip that you would plug into your motherboard there if it supports it. So what's this thing actually doing? So what it does is it gives you hardware encryption. So we understand what encryption is. We won't go into all that, but you do encryption with software. And that makes it a little bit more vulnerable. If you build it into the hardware, it means that all your hardware components can now benefit from encryption at the hardware level. So, for example, when you store data on your hard drive, instead of just storing sort of the raw binary, as it were, which would be very easy to kind of look at and see what's there, what you can now do is put a hardware level of encryption on the data that's stored to the hard drive, and that makes it obviously significantly more secure. Now, why would that be necessary? Why is that a thing? Because I haven't got hackers coming in and ripping the hard drive out of or the solid state drive out of my PC and inspecting the bits on the drive. So why is that a thing? Well, they reckon that this can reduce malware, which obviously is quite a big thing. It can reduce the effects of malware by about 60%. And we know that things like ransomware that automatically sort of encrypt your files and do all those sorts of things is an absolute menace. And so being able to protect against things like that at a hardware level is absolutely fantastic. The other thing, of course, is that when you type in passwords, if you're just storing passwords in plain text, then that's not very secure at all. And obviously to log into Windows itself, you might have to type in your password. And if you can sort of protect that with hashing algorithms at a hardware level, then you've got an significantly increased level of protection there. So this TPM chip is all about making the data that's stored on your drives significantly more secure. That's what that's all about. And Windows want to make sure that their operating system isn't sort of a leaky sieve. They want to increase the security of that operating system. I mean, traditionally, it's been a bit of a problem.
So that's a basic requirement, and without that, you won't be able to install Windows 11. That's interesting. Incidentally, I mean, if you are curious, does my current PC meet the spec? You literally can type in Windows 11. Microsoft have a launch page, and they have a little app on that web page there, and you can just click it, and it will run a check of your system, and it will let you know whether your system will accept Windows 11 when it comes out or not. So finally, then, graphics card. So yes. Minimum graphics card compatible with DirectX 12. Blimey, I remember DirectX sort of 1, 2, 3, and WDDM 2.0 driver. Oh, sorry, I thought there was a picture coming on after that. There is not.
No, there's no picture of a driver.
Well, I thought you might have a pretty graphics card image coming up.
No. So before I get into that, just very quickly on the TPM, I probably should say you don't need to know about that for A level. You don't need to know about it. This is just sort of, a bit of general knowledge for you. However, encryption is on the specification. You do need to know why encryption is important, and you do need to understand hashing algorithms and what hashing is all about. So, it does sort of tip the hat to that. So I won't talk about DirectX and all that, but what is WDDM driver? I thought it would be worth just a quick mention on what this is, because again, let's link it back to the specification. So firstly, you need a driver for your graphics card so that the hardware component and the operating system can talk to each other, so they can share instructions, okay? It's a little bit like a translator. So you need to know what drivers are generally. But of course, what that enables you to do is actually show Windows on your monitor. You need to be able to see the interface of the operating system on your monitor. So you need a graphical
user interface, after all. Yeah,
yeah, exactly. So you need a driver, okay? But the other thing that it does, a couple of other things it does, is it allows the paging of video RAM into your main RAM, okay? So graphics cards have their own RAM to store their own data. Okay. And we understand from the theory side of things that if your computer runs out of main RAM, physical RAM, then it can use sort of logical RAM by paging that off into virtual memory. And it's using your hard drive as if it were memory. It's not executing instructions from there. It still has to page them back into the RAM to execute them. But it's able to kind of offload part of the RAM onto the secondary storage so that you don't run out of RAM effectively. Well, what you've probably never thought about is, well, what happens when the video card runs out of RAM then? Okay, because it can, all right? So exactly the same thing's happening with the graphics card. If the graphics card runs out of its own RAM, it needs to page that off. So instead of paging it off to secondary storage, which would be ridiculously slow, then perhaps page it off to the main RAM. So in other words, use the computer's main RAM as video RAM, okay? And so the WDDM driver enables you to page the graphics memory, which is quite interesting.
An interesting trade-off there, isn't it? Because it's always about trying to, one, not stop what's currently happening. If we get to a situation where we have to freeze or we can't do it, that shouldn't be allowed to happen. So, RAM falls, video memory fills up. And then the second thing is, well, making sure we can carry on as seamlessly and efficiently as possible. So falling back to the next best option. So, I mean, typically, I guess an average desktop PC these days, if it wasn't a real budget model, probably has around sort of 8 gig of memory, somewhere between 8 to 16, and 4 maybe. But that's the sort of average amount. And a graphics card may have 512 or a gig. I mean, graphics cards are coming out with 1 or 2 gigs of memory, but if you're getting those, you've probably got a PC that's got 16 or 32 gig. But the point is there, whatever the comparison, the amount of main RAM you have is typically significantly bigger than the amount of RAM you've got across your 1 or 2 graphics cards. So yeah, being able to do that, and you're saying that is effectively what the WDDM 2.0 driver allows. One of the things it allows is the falling back of that graphics memory to your main memory before falling back, say, to virtual storage on a hard drive. That's interesting.
Absolutely.
I didn't know that.
Yeah, absolutely. And you know, if you're thinking about buying a PC, obviously, you know, get the fastest processor that you can afford with the maximum number of cores that you can afford. You know, that you definitely want to be having a look at that. But secondarily, always get the biggest amount of RAM that you can afford in your PC and in your graphics card, because that is going to make a difference, as Craig said, because you won't have the fallback. Now, I've got quite an old graphics card. I've got a 1060, but I deliberately chose the 6 GB model because of the performance increase you're going to get with extra RAM. And so something for you to just sort of bear in mind there, you know, RAM is going to make your computer faster. It'll make your graphics card faster. So so there you go. The other thing that this driver is doing is it's doing scheduling. Now, again, on the A level, we talk about the scheduling algorithms: first come, first serve, round robin, shortest job first, shortest remaining time. And we always think about scheduling the main CPU and, you know, what instructions is it going to do next and that kind of thing. But rarely do we ever consider that the same thing must happen on your graphics card. If your graphics card has got its own processor and it's an independent processor and it has its own RAM, then it needs to schedule its own instructions as well, okay? And so your WDDM driver is doing scheduling of graphics processes. So where your graphics card is obviously doing a lot of calculations on polygons, that's what graphics cards do, it has to schedule those. And so it's running scheduling algorithms, and that's part of what this driver is doing. In addition to that, it's allowing meshing. Now, what meshing is, just very briefly, is graphics are made up of polygons. Okay, you know what a cube is, for example. Okay, that's a polygon. And graphics are made up of lots and lots of triangles. Okay, and what you can do is you can have one application that's creating the meshes, creating the triangles. And then you can have another program that's using those triangles. And the WDDM driver facilitates that. It allows one application or one process to create the meshes and another process to then use those meshes. And so that's quite nice. And finally, the last thing that it's kind of doing for you is fault tolerance. So again, it's a misconception that things never break. But they do. I mean, your graphics card, for example, can have a fault. Okay. And I'm not talking about a hardware fault. There might be a software fault. There might be a glitch. There might be something that causes, you know, that graphic instruction not to be able to execute, in the same way you get, you know, faults on the CPU, faults with code on the CPU. So what you do if you get a graphics fault, you just kind of lock up and it's like, got to reset my computer. You know, that's a bit disastrous. It would be better if there was some kind of fault tolerance in there. And, you know, what you could do is just sort of reset the driver. Now, it's interesting that Craig was talking about the Apollo computer earlier, because that had a similar sort of thing in it, that if it came across a fault, it could just reset itself, just reset the computer. And that's effectively what happens in your GPU. So with the WDDM driver, if it comes across a fault, it just resets the driver, and, you know, chances are, you know, clear the memory out, clear the instruction scheduling out, kind of start it again, and everything's fine.
I hate to say it, it's the good old turn it off and turn it on again approach.
It absolutely is. So if you can automate, you know, switch it off and switch it back on again, then you've solved your problem. Yeah. Yeah.
Oh dear. Right. Well, there you go, everyone. So yeah, a little trip through Windows 11. I mean, let us know what you think in the comments. Are you excited about the next version of Windows operating system? Is it just a fad for you? Are you a Mac user and you've seen it all before? Let us know what you think. But yeah, thanks for sticking with us for another Unscripted. And yeah, we'll catch you next week. Cheers, everyone. Bye-bye.